Welcome back to Saxon Math. This is lesson 82, volume of a rectangular prism. The volume of a shape is the amount of space that the shape occupies. We measure volume by using units that take up space called cubic units. The number of cubic units of space that the shape occupies is the volume measurement of that shape. We select units of appropriate size to describe a volume. For small volumes, we can use cubic centimeters or cubic inches. For larger volumes, we can use cubic feet and cubic meters. To calculate the volume of a rectangular prism, we can begin by finding the area of the base of the prism. Then we can imagine building layers of cubes on the base up to the height of the prism. The base of a rectangular prism is one of the two parallel and congruent rectangular faces. So if this was representing 1 cubic inch, you could layer another cubic inch on top of it, and that would be another layer. This would be considered the base in that case. So how many 1-inch cubes are needed to form this rectangular prism? So if you look at it, it has this as the base. You can see that there are 3 going this direction. So that'd be 3 cubes going this direction, and then there would be 5 cubes going this direction. So you see that those 5 and those 3 is 5 inches times 3 inches that equals 15 inches squared if we were looking at the area of that base. Now we also need to include that there are 4 of those. So you see that there's 1, 2, 3, 4 layers of those. So we're going to multiply that times 4 inches. And when we do that, we end up with 20 here. And then we'd add that 2, which makes it 60. 60 inches cubed would be the answer. So you'd end up with that as your final answer for the cubic amount, or the volume of that particular rectangular prism. So the formula for the area of a base is simply length times width. If we were looking for the volume of the entire rectangular prism, we have to remember that it has the first layer, the base layer, and then there are 3 additional layers on top of that. So notice in the example above, we multiplied the length by the width to find the area of the base. Then we multiplied the area of the base by the height to find the volume. We can calculate the volume of a rectangular prism by multiplying the 3 perpendicular dimensions of the prism: the length, the width, and the height. Thus, the formula for finding the volume of a rectangular prism is length times width times height. And the questions here: does the order in which we multiply dimensions change the answer? Why or why not? And it would not. You can order that in any order. It wouldn't really matter if you chose to multiply 3 times 4 and then times 5, or 5 times 3 and then times 4. You're still going to end up with the same final answer. In this case, it would be 60 cubic inches, because you're multiplying the length times width times height, and you're multiplying the 5 inches times the 3 inches times the 4 inches, and that makes 3 of those inches. You've got 1, 2, 3 in that case, and 5 times 3 times 4 equals 60, and then it would be cubic inches, or an exponent of 3 for the inches. What's the volume of a cube whose edges are 10 centimeters long? So the volume again is length times width times height. And if all of those edges are the same, it's simply 10 centimeters times 10 centimeters times 10 centimeters, which would equal 1,000 centimeters cubed, or cubic centimeters. So the area of the base is 10 centimeters times 10 centimeters, or 100 square centimeters. And then you would have 10 of those layers all the way to the top of that prism, and it would end up being 1,000 cubic centimeters. So in addition to volume equals length times width times height, what other formulas could we use to find the volume of a cube? You could actually say that the volume of a cube equals the edges cubed. So the length of, if it's a cube, it means it has the same length as it does the width, and it also has the same height. So you could just take that edge and cube it, which is the same as 10 centimeters. And then if you were to cube that, in this case, for this particular length, 10 centimeters was one of the edges, and it's a cube. So then you have to take 10 times 10 times 10, and it'd be centimeters cubed. So that'd be 1,000 centimeters cubed, or cubic centimeters. Example 3, find the volume of a rectangular prism that's 4 feet long, 3 feet wide, and 2 feet high. So again, the volume equals the length times width times height. And I see that it's 4 feet times 3 feet times 2 feet. And my volume's answer is going to have a label of cubic feet, or feet cubed. So once I find what 4 times 3 times 12 is, that's what the answer will be to the volume of rectangular prism that has those lengths. So 4 times 3 is 12, and 12 times 2 is 24. So the volume of that rectangular prism would be 24 cubic feet. All right, let's look at another example here. If Allison put small cubes together to build larger cubes, she made a table to record the number of cubes she used. So each length of the edge was 2 here. That meant the volume of the cube would be 8 units cubed. If the length of an edge was 3, it was 3 times 3 times 3, which ended up being 27. If it was 4, it was 4 times 4 times 4, which ends up being 64. 5 cubed is 125. So given this pattern, describe a rule that could be used to find the volume of a cube. So you could just have, in this case, since we can use a pattern to help us find the rule to determine the volume of a cube, in earlier examples we multiplied the length and the width and the height. For a cube, these 3 measures are going to be the same, they're equal. We can see that 2 times 2 times 2 is 8, and 3 times 3 times 3 is 27. Thus, cubing the edge of a cube gives us the volume, or volume equals the edge cubed. So that would be the rule or the pattern that we could use to find that. All right, let's try this. Practice letter A. How many 1 centimeter cubes would be needed to build a cube 4 centimeters on each edge? So you see that it's a cube, and if it has 4 centimeters and 4 centimeters and 4 centimeters, we could use that edge equals the edge cubed, which is, in this case, the volume would be then 4 centimeters, and that would have to be cubed. So that means 4 times 4 times 4, and the volume's answer is going to be with cubic centimeters. So I need to do 16 times 4. When I multiply that, I get 24. Carry that, that would be 4, that would be 64. So I can see that it would be 64 cubic centimeters. And letter B, what is the volume of a rectangular box that is 5 feet long, 3 feet wide, and 2 feet tall? So the volume equals length times width times height. In this case, I see that the volume is 5 feet times 3 feet times 2 feet. So and then I have the volume equaling something with cubic feet. 15 times 2 would be 30. So the answer would be 30 cubic feet. The interior dimensions of a rectangular box are 10 inches by 6 inches by 4 inches. The box is to be filled with 1-inch cubes. How many cubes can fit on the bottom layer, and how many cubes can fit in the box? So again, I'm going to look at this as in volume equals length times width times height. And that will answer how many cubes will fit in the entire box if I use that formula. If I want to find how many will fit in the bottom layer, I'm going to use 10 inches times 6 inches just to find out what's in the bottom layer. So this length times this width will get that bottom layer. So that would be like area equals length times width for the bottom layer. So the first question is simply going to be answered with 60 inches squared. And for the volume, we'd have length times width times height, which is simply going to be that 60 times 4. So 60 times 4 is the same as 240. So the volume would be 240 inches cubed. Volume is those 3. So you have to do it cubed. When you're only doing area, you're only doing 2 of them. And letter D, choose the most appropriate unit to measure the volume of a refrigerator. Would you use cubic inches, cubic feet, or cubic miles? Hopefully you answered cubic feet, because cubic inches, it would just take thousands of them to make up a refrigerator. Cubic miles, we're obviously not traveling miles. You can't fit something that is that large in your kitchen. But cubic feet would represent the most appropriate measure for the volume of a refrigerator. All right, that's it for today. If you missed anything or didn't quite understand it, go back and review the video. And remember, written practice 1 through 30 is very important. You need to do it to learn any of the previous lessons better and practice. All right, have a great day.